All right, it's been a wild day in math today. I've had computer problems. I've had people coming by, phone calls I've had to take. Crazy day thus far. We're in geometry now, third class of the day, the 23rd of January, third week of the second semester. That would be 12 weeks left after this week. And so we are in geometry on lesson 50, starting a brand new chapter in your teaching textbooks curriculum. And thankfully, after a few weeks of those inequalities, I were a little bit difficult, I'll gather. And so we're going to go into quadrilaterals now and polygons, quadrilaterals. Uh, because it's the first lesson, it's actually going to be a little bit easy. Let me move my camera so it's right in the middle. So it looks like I'm not, so I'm looking at the camera and such. So that being said, let's jump into these problems. Okay, let me give you some thoughts here. Let me pull up the whiteboard and see if we can make some sense of these things. Okay, if I do this view, it makes me larger. So let me do that. Oop, not that view. Let me see if I can get this right. Yeah, there we go. Okay, so somebody either type with your chat or put your audio on. Tell me what the prefix poly means in English, in any setting. Anybody know?
Doesn't it mean, I could be wrong, but doesn't it mean like many or something?
Okay, very good. Yeah. And that's a great definition. A little bit more specific, though, Bella, is this. I called you Bella. Can you believe that? I didn't even call you Dr. J.
I know, what is this?
um, we'll just say poly means more than one. Okay. Like, for example, some nations are what they call their religions are monotheistic, and some are polytheistic. So we see this term not only in math, we see it in other things. Mono means one, poly means many. Theos is God, so one God, many gods. Okay, so no debates on those things today. You could be either of those things you want to be, or none of those things. Or if you're atheistic, right? The suffix a means none. So none, one, many. Okay, and any of those things you want to be, no debates on that. No emphasis at all on my part, which of those would be right, wrong, or indifferent. You're free to do whatever you and your parents want you to do. So, but that's where we see the word mono and poly. Okay, so now we have the word in geometry called polygon. Okay, so polygon simply means this: a shape that has at least two sides. Okay, but in order for it to be a shape, you're going to start with the third side, which would be a triangle. So we spent the better part of, I don't know, 5 or 6 weeks talking about triangles. Tri is a prefix that means, and you say, Mr. Soto, we're not in the third grade. I told you today's going to be easy, though. After all these hard lessons that we've been doing, isn't it nice to have something that's a little bit more elementary? Okay. So tri means three, like tricycle or tripod. Okay. Okay. So then you get to, so we've done all this triangles, I should say. Okay, now we're going to go into more polygons, but now we're going to go into polygons of quadrilaterals. And I'm going to make sure I spell quadrilateral correctly. Okay. And you've already learned quadrilaterals. You learned quadrilaterals in the third grade, in the second grade, and there's lots of different kinds of quadrilaterals. A quadrilateral, in all review, is a side that's completely in, I'm sorry, a shape that's completely enclosed that has at least, I'm sorry, I shouldn't say at least, has exactly 4 sides to it. It could be a square. It could be a rectangle. It could be a trapezoid. And all these are examples of quadrilaterals. Okay. So, and it could be a parallelogram. It could just be any quadrilateral that's none of those things. Okay. So some random shape. It looks like this. Okay. So we know that all 1, 2, 3, 4, 5 of these shapes are called quadrilaterals. Kind of the quintessential quadrilateral is a square, because by definition, a square is also a rectangle, but more specifically a square. It's also a quadrilateral, but it's, so again, so anyway, so let me say that. Let me give you some other thoughts as well. So I think you all know all those things I've just told you, but we're going to get into some more detailed things. So let's kind of review along the way for you. Okay. In order to be a quadrilateral, you're going to need to have 4 angles inside of it. You're going to have 4 sides. It's going to have to be fully enclosed. And once it meets all those parameters, it's a quadrilateral. Like, for example, the next, a pentagon would be the next polygon in order of having angles, and a pentagon would have 5. That's why the largest square footage building in the world, did you know that is at least in the United States, I should say, the largest building square footage wise in the entire United States is the Pentagon, which, as you probably know, was attacked on September 11th when none of you were even born. But you also might not know this. It is where all of the defense of the United States, all the 5 branches of military have their headquarters at the Pentagon, meaning the Army, the Navy, the Air Force, the Marines, and the Coast Guard. Those are the 5 branches of U.S. military. Each of them have their headquarters in the Pentagon. And the reason it's called the Pentagon is because it's actually shaped as a pentagon. It's got 5 sides to it, and each of the sides has, buildings. It's only like, not really tall as far as buildings go. It's like 7 stories, but it's so wide. It's the largest square footage building in all of the world. I'm sorry, in all of the U.S. And it was actually built, just so you know, because Mr. Soto teaches you random things that you might need to know later on in life that don't have to do with math, but are somehow vaguely connected to math. The Pentagon was actually constructed post World War II, when it was decided that it would be good for all of our militaries to be headquartered in one centralized location, hence the building of the Pentagon. So this is actually a 5-sided and a 5-angled shape. Today we're learning about 4-sided and 4-angled shapes. Okay, so here's another thing that we know. Inside of a triangle, the sum of all the angles is 180 degrees. Inside any true quadrilateral, the sum is going to be 360 degrees. Okay, and you might say to yourself, well, doesn't a circle have 360 degrees in it? And I would say, absolutely it does. But let's look as to show you why. A circle is 360 degrees. Any snowboarders out there, skateboarders? I remember when Tony Hawk pulled off the first 720 on a vert ramp. Okay. He made 2 full and complete rotations on his board. He had to come in fakie and do 2 full rotations to do a 720. 360 and 360 is 720. He did 2 complete circles. Okay. So let me show you why a circle has 360 degrees and why a square would also. Now watch. I put this little cross section of a circle and look, 90, 90, 90, 90. Okay. What's 90 times 4? 360. And so you'll see here that this one part of 1/4 of a circle cut in half both ways, perpendicular to each other, 90 degrees would create 90, 90, 90, 90. So you can see that a circle relates to a square in this capacity. All right. Thumbs up right now if you completely understand the things I've said, but you're simultaneously completely bored and wish we talk about something different. Anybody? Count 3, 1, 2, 3. Okay, everybody bored out of your mind. Okay, here we go. Let's go back to our shape up here. Let's call this, let me clear this all off. Let me start over because I have too much mumbo jumbo here. This is just a random quadrilateral. Erase that line there. Okay, we'll call this A, B, C, and D. So it's a polygon because it has more than one side. It's a quadrilateral because it has 4 specific sides with 4 specific angles that are completely enclosed. The fact that they're completely enclosed means it is a quadrilateral, which also means the sum of all of its angles would be 360 degrees. If it were a perfect square, it would have 4 right angles, and right angles are 90 degrees by definition, and 4 times 90 is 360. If it was a rectangle, it would also have 4 perfectly symmetrical right angles in each of the 4 vertices. Again, 90 times 4 is 360. This one, however, is not a square, nor is it a rectangle. Okay, let me give you some things that you'll need to know. Okay, the vertices is the plural of vertex. We've learned that already. Okay, it's the angle formed at intersecting lines. AB and AD have a common vertex of angle A. We can turn it into an angle BAD. It's bad, right? BAD. So here's the vertex. And by the way, the plural of vertex is vertices, plural meaning more than one. 1, 2, 3, 4. 4 vertices here, A, B, C, and D. Okay. These are called consecutive sides. AB is consecutive to AD. They're not congruent, they're just consecutive. Okay. So AB, and again, on sides, you can reverse the order. A little harder on angles and triangles. They got to go in a flowing order. But for sides, you can reverse those as we taught you before. So you can say AB or BA. You can say AD or DA. That's okay. But AB or BA, if you want to, is consecutive to AD. Okay. You also can have consecutive angles. Angle A and angle B are consecutive, meaning they go one after the other. So B is consecutive to A, D is also consecutive to A the other direction. Okay, so you have consecutive sides, consecutive angles. Okay, you're also going to have opposite sides. So BC is opposite AD. BC is opposite AD. And also angles can be opposite of each other too. Angle B is opposite of angle D. Okay? There's one other thing they wanted you. Oh, you can make diagonals as well. So you have the ability to take this and you can make diagonals connecting B to D. That makes two triangles here out of this quadrilateral. Here's a tidbit of geometry for you. Okay, so here's some geometry for you. We'll get to the teaching here in a second. We know that the area of this rectangle that I've drawn here would be 3 times 4, which is 12, right? Now, what is the formula? Because area of a rectangle is just simply length times width. Is that right? The area of a triangle is equal to half the base times the height. Okay. So we would know this. Watch. Half the base times the height, 4 times 3, 12. Half of 12 is 6. Watch. 6 and 6 together is 12. So you can see how half the base times the height makes sense. That's area. So I'll put units squared. We also know that this would be a right triangle, right? A squared plus B squared equals C squared. So we have 9 plus 16 equals 25. And the square root of 25 is 5. That's how you get the length of this hypotenuse. The area of this is 6 units squared. The length of the hypotenuse, because this is a right triangle, is 5, because 3 times 3 is 9. 3 squared plus 4 squared equals C squared. So C squared is equal to 25. Radical, radical. C equals 5. Boom chaka. That's fun for you. All right. Again, lots of things that are kind of easy today. Just teaching you some things. Let's go ahead and do our sheet here. We'll start problem set 50 right there. All right. You still there? Thumbs up if you're still there. All right, cool. All right. Let's do number 1. A quadrilateral is a polygon that has 4 sides. That'd be true, right? Polygon just means more than one. So a triangle is a polygon, a hexagon, an octagon, a septagon is those are all polygons. Quadrilateral is one that has 4 sides. Yes, that's true. Number 1. The sum of the measures of the angles of a quadrilateral is 180 degrees. That would be false, right? So 360. Back to my little illustration that I gave you, because it's Mr. Soto's job to teach you things that are of the utmost importance. Here's our circle again. We know a circle has a 360-degree measurement. Okay. Here's your 180 and your 180 as well. Remember I told you the circle relates to the 360 because of this. Back to those illustrations that I taught you. If you took your illustration, cut it in half, again, back to 180 180. There's a total of 180 degrees inside of a triangle, 180 inside of a triangle. You put two triangles together, you get a square, or this thing's a rectangle. 180 plus 180 is 360. So there it is, all matching together. That's fun. All right, so here we go. Number 3, because we're having fun. Blank sides of a quadrilateral are the sides connected by a vertex. Again, that's worded a little differently than I said. Let me illustrate it for you again so you can get the right answer because you're smart. I have a message for Hannah and for the Duskov siblings. Duskov, how do you pronounce your last name, Miriam? Duskov?
Duskov.
Duskov?
Duskov.
Okay.
Yes.
We have 2 students in the class that you've never met before because they were here the first week and then they're gone. They're gone for 2 weeks for vacation. Then they had a funeral that they had to go to 2 more weeks. So you won't even get to meet them. They're brothers also. They are Benson and Adrian, 2 brothers. So, but anyways, that's all. Okay, so in our quadrilateral that we have here, this is A, B, C, D. So it's consecutive if it's 2 sides connected by 1 vertex right there. This is the vertex. The 2 sides are connected. So consecutive sides of a quadrilateral are sides connected by a vertex. AB and AD are consecutive because they're connected by 1 single vertex. Letter A, number 3, letter A. Okay? Blank angles of a quadrilateral angles located at alternative vertices. Alternative is opposite sides. Opposite. You could put a diagonal if you want to connect them, but they are letter E, opposite. So for number 4, look at it. Opposite angles of a quadrilateral are angles that are located at alternate vertices. Again, vertices is the plural of vertex. So you have 2 vertices. We learned this already in number 5. We know that converse and inverse are basically the same way of saying the same, or is a synonymous way of saying something. If something is inverse of each other, it's also converse of each other. And that's where the Converse shoes get their name from. Who's wearing Converse shoes right now? Anybody?
I'm barefoot right now.
You're barefoot? All right. Are your feet cold?
No, I got my fuzzy socks on.
All right. Cool beans. All right. I'm wearing shoes I've never worn ever in my life, and I'm wearing them for the first day today. I'm wearing Doc Martens right now. My wife got me a pair of Doc Martens. So she tries to make me cool and hip. When we first started dating, I was kind of nerdy and she was cool. And so now I'm a cool nerd thanks to my wife. But I never made her a nerd. She's still cool. I was a nerd. She was cool. She made me a cool nerd. But I didn't make her a cool nerd because she's just still cool. But that's okay. So number 5, the converse of a statement is always logically equivalent to the inverse of that statement. We learned that already. Letter E for number 5, inverse. All right. Number 6 on the back side there. If 2 sides of a triangle are not congruent, then the angles opposite those sides are also not congruent. So we know that we can eliminate B and D in that scenario because it's got to be A, C, or E, right? If 2 sides of a triangle are not congruent, then the angles opposite those are also not congruent. And the greater angle is opposite the longer side. And that's what we learned before. The greater angle is the longer side. So we learned that when you have like that, I'll randomly throw this as a 5, and this is an 8. We know that this is the greater angle than this one, because this side's longer here. The 9 is bigger than the 5, so this angle here has got to be larger. This angle here has to be, let's call this A and let's call this C. A has to be greater than C because 9 is greater than 5. And it converses that way as well. So if you had the measurements of the angles of this was, let's erase these and call this B. If this was 50 and this was 40, you would know that BC would be greater than AB. Okay, we learned that a lesson or two ago. All right, that being said, so far so good, thumbs up. So it's letter C, by the way, for number 6, letter C. If two sides of a triangle are not congruent, then the angles opposite those sides are not congruent either. And the greater angle will make the longer side, and conversely the same way. The longer side will be opposite the greater angle. That's where you get the greater than, less than inequalities that we so painfully learned the last 5 or 6 or 8 lessons, however long it was. Okay. Fun, fun, fun. Again, I told you not the most difficult stuff we've learned thus far. So let's go to number 7. And I'll have a couple bonus ones for you that you don't have. I'll draw them for you because Mr. Soto is capable of doing those things. Number 7, list each of the consecutive and opposite sides of LKIO. So we have LKIO. LKIO. Doesn't appear to be a square, doesn't appear to be, kind of looks trapezoid-ish, but it even doesn't appear to be a full trapezoid. Mine looks more like a trapezoid than the one that you have on your paper because it looks more like this, right? A little bit more like that. All right. Put L right here. And also, this is not fully enclosed, though it should be. All right. So we need to find the consecutive sides of the, so LK, KI, KIIO, IOOL, and LOIO. Those are the consecutive sides. The opposite sides are LK, IO. So which of those 5 letters, A, B, C, D, or E, has consecutive sides correct and opposite sides correct? You tell me. 4 and 5 were EE. Miriam, since you asked. Miriam, I remember when your brother Daniel was in my class, you guys would hang out right in the outside. Remember I used to give you a hard time? Like 2 years ago, Miriam, you remember that?
Yes, of course.
And I talked about your name, Miriam. I'm not sure why.
It's
It's all good. You didn't like me back then, did you, Miriam? You thought Mr. Soto's a weirdo.
No, I never said that.
All right. Mr. Soto's a meanie. All right, who's got a guess for those 2 questions? It would be, you got to go LK, KI, KI, IO, comma, IO, LO, LO. Okay. Okay. For the consecutive sides, you're going to have at least the pairings go 4 different pairings. So can't be letter B because of that. Letter D, right? Look at it again. Letter D. There you go, Ariana. Yes, letter D. All right, y'all see that? Thumbs up if you see it for number 7, it's letter D. Count of 3. 1, 2, 3, go. Y'all, Mr. Soto, I'm playing my video game, just filling in the answers as I hear you say it. All right. Letter number 8, why don't you try that one? Consecutive angles, then opposite angles. A little bit of process of elimination I see, but that's okay. It's good for you. All right, you work on that. I'm going to clear this guy off since you have that written for you there. And I'm going to draw number 20 for you, and you're going to solve this for me. Then I'll help you to make sure that you have it. E, good job. All you E people, several of you did that. Yes, for the number 8, E is the correct answer. Thank you for that, for the participants. Okay, this is number 20. So you get a head start on that. You can draw it yourself, write it out. We want to solve for Y. This is 85 degrees, 127 degrees. This is 62 degrees. I know it's hard to read my chicken scratch on this tablet thing I write with. You got to solve for the measurement of angle Y. I know you don't have it, Ariana. I wrote it down for you. Yeah, this was not on your sheet. I just thought when I was preparing for the lesson, I thought we're going to get done pretty quickly because I'm going to teach you things you learned in the 3rd and 4th grade again. A lot of times when they have the very first lesson of a chapter, they start off very simple, and that was today. So I knew we'd be done a little more quickly, so I scrolled back through and I did a couple of your problems, a couple more of your problems. We've already done 8. So when it's all said and done, I'll have done half of your work for you. Very nice of me. All right, I got a couple answers already. Anybody else? Does anybody put your hand up if you don't on your thing if you don't know how to do this? So you all know how. Okay. Several of you sent over something. Let me show you again. Okay, got a couple of answers. We got a couple of different answers. We'll see who's right. Okay. I got another different answer. Okay. All right. So what I have to do here is this. I have to find the measurement of this angle here. So I'm just going to go 180 minus 85. And I'm guessing that would be 95 if my math is correct. Because minus 80 would be 100, 5 more. Okay, so this is going to be 95 here. So now what I'm going to have to do is add these 3 up, then subtract it from 360. Okay, so I'm going to go 127, 62, 95, 7, 8, 9, plus 5 is 14, 6, 7, 8, 9, and 9 is 18, 1, 2, 284, 360 minus 284, 10 minus 4 is 6, 5, 15 minus 8 is 7. 2 minus 2 is 0. If you said 76 degrees, you are absolutely correct, Mundo. I did see at least one of you that said that. Maybe two of you said that. A few of you had, Ariana, I saw what you did and you just, yeah, actually you caught what you did there. So again, you may have assumed that there's parallel lines there. So, 2 hands up. Okay. All right. Did you see it now? Are you raising your hand because you were answering my question, or you have a question, Alex? A different question. Oh, yeah. Okay. I'm going to mute my device, by the way, in case somebody leaves me a message. So give me 1 second. I'm going to mute my device. All right, no message. What I have to do in case somebody left a private message, because I'm recording our class and I'm going to upload it. Somebody's going to leave me a private message. I'm at my office at the church that I'm a pastor of. So this is number 19. You don't have this either. I'm just drawing it for you. All right. They want you to solve for X. One more thing. You're solving for X. And this will be our last problem to do. This is number 19. So I did 19 and 20. You don't have that, but it will be on your teaching textbooks when you do it, just like I showed it to you. So you might want to write the answer down because we're doing your work with you. Send me over an answer when you get done. This is lesson 50 on teaching textbooks here. Lesson 50. You're welcome. All right, a couple of you have guessed. Anybody else want to send over a guess? Okay, what we're going to do is this. We're going to first solve for this angle right here. I won't call it X, I'll just, this angle right here. If this is 60 and this is 70, that's 130. Together, the sum of the three angles is 180. So 180 minus 130 is 50. If this is 50, then this here is 50 also because vertical angles are congruent. Okay? If this is 50 and this is 50, then this is 50 and this here is 50 because alternate angles when cut by a transversal, we learned this earlier in math. If you're just joining us this semester, you might not have learned this, but we know that when you have parallel lines cut by a transversal, these angles are congruent to each other. So if this is 50, this is 50. Well, if this is 60, this is 50. We know that if 50, 60, 70 would be the last amount. Because again, 50 and 60 is 110. 110 subtracted from 180 is 70. X would have to be 70 degrees. So for those of you who said 70, you are correctamundo. That is the correct answer. So that is it for the day. We'll finish a few minutes early if that's okay with you. Any last minute questions? All right. It's been real. It's been fun. It's also been really fun. Mr. Soto, signing off.